We are looking at a piping and instrumentation diagram, a P&ID, for a high-stakes industrial project undergoing its definitive review phase. During this phase, the engineering team methodically checks the standard metrics. They verify the flow rates. They confirm the pressure tolerances. They trace the control philosophy logic. Everyone at the table reaches the same conclusion. The math works, the routing is sound, and the design is ready for construction. But a clean paper review creates a dangerous illusion of safety. Passing these operational checks can easily mask structural blind spots that only become obvious once the system goes live. That blind spot appeared months later, right in the middle of commissioning. The timeline came to a complete halt when workers tried to perform routine equipment maintenance. The operational requirement was straightforward, but non-negotiable. The maintenance team had to safely isolate a piece of hazardous equipment from the rest of the active pressurized plant. On paper and in the field, the standard isolation valves specified in the P&ID were fully installed and tightly closed. Yet the work stopped because of a fatal design omission. The schematics lacked any dedicated positive isolation arrangement. Without a way to completely sever the pipeline connection, maintenance planning froze. Commissioning was delayed indefinitely. A single missing detail during a conference room review translated directly into massive financial bleeding and operational paralysis on a live construction site. An industrial valve's purpose is to actively halt the directional flow of fluid, but internal seals degrade over time, allowing microscopic volumes of fluid to push past. With hazardous materials, this leak becomes an unacceptable risk for the worker. This vulnerability leads to an absolute rule in piping engineering. Stopping flow with a valve is never the same as safely isolating an area. Relying solely on mechanical seals to protect human life delegates safety to a degradable component. To guarantee safety on hazardous pipelines, the industry mandates a structural requirement known as positive isolation. We see a specific hardware solution, the spectacle blind. It's a figure-8 metal plate physically rotated into a pipe joint to cap the opening. Alternatively, a metal spade is physically slotted between flanges. These tools create an impenetrable metal wall. This physical hardware completely neutralizes the threat of hazardous material leaking through. It allows maintenance crews downstream to work without any risk of exposure. Engineering safety depends on the physical elimination of a hazard pathway. By removing the fluid's path entirely, the design replaces mechanical hope with physical certainty. Which brings us back to the initial P&ID review phase. There is a sharp dividing line between what novice reviewers check and what seasoned engineers look for. Experienced reviewers project the entire life cycle of the equipment. They look past day one operational flow to anticipate inevitable long-term life cycle events. Looking at this detailed P&ID layout, a master reviewer will isolate a specific piece of equipment and demand to know exactly how it will be safely taken offline for maintenance years in the future. This leads to a strict schematic checklist. First, reviewers actively trace hazardous service routes. Second, they pinpoint exactly where workers will need maintenance access points. Finally, they ensure positive isolation hardware is explicitly drawn adjacent to those standard valves. Flawless engineering design proactively secures the safety of future maintenance workers by treating every life cycle event as a primary technical requirement.